All right, let's go ahead and get started. This is the last of the RightStart Math online conference sections. I am Kathleen Cotter Clayton, and with me I have Dr. Joan A. Cotter, who's also going to be joining me. What we are talking about here today is fractions. And just a second here. We have fractions, and this is all the things that we're going to talk about here today, directly pulling from the fractions chapter from Dr. Cotter's upcoming book, Start Math Right: The Journey to Mathematics Excellence. So without further ado, Dr. Cotter, do you want to say hello real quick for those who haven't met you before?
Hello, I'm Joan Cotter, and I've had fun listening to these people talk about the book, and I hope you find it interesting as well.
Good, thank you. All right, without further ado, let's get started. I'm going to start off with a story of two hamburgers. Just a second, I got to move something out of the way here. Okay, this is going to be the story of two hamburgers. So in 1972, McDonald's, oops, I got my computer to work here. There we go. McDonald's debuted their quarter pounder burger, which we all know has sold billions all around the world. Whether you like them or not, a lot of people like them. Well, a couple years later, A&W was like, oh, that's a really good idea. Let's make another one, but I'm going to make a bigger and a better burger for the same price. So they did blind taste tests and they did all sorts of things, and customers really liked the A&W one, and they called it the third burger, but it didn't sell. Why not? Well, customers thought that a third pounder was smaller than a quarter pounder, so therefore it should cost less, even though it was bigger, which I thought was hilarious. So they thought that because, again, 3 is less than 4, a third must be less than a fourth. Therefore, the third burger, or the third pounder should be less money because it was less hamburger, which was not the case. Well, A&W ended up dropping it, which is why many of you probably don't even remember the third pounder. But when they dropped it, the officials, the A&W officials said the customer, regardless of his or her proficiency with fractions, is always right. And so they did drop it. So problems with fractions have been going on for a long time, and of course, a lot longer than 1972. But this has been a chronic problem in basically our world, but definitely our culture. We've got a lot of confusion with fractions. Most people aren't even sure what a fraction is. You think about it, you can write it as a 1/3 or 1/3, or if you're in the UK, you write it like that. So you've got all these different ways to write it. And then you mix up things like the ordinal number names, like third and fifth and sixth. How does that relate to 3, 5, and 6? But you got third, fifth, and sixth. And then you throw in words like half and quarter. I mean, why is it? Of course, you can say 1/4, but a lot of people use quarter, and the kids don't get it. And that adds to the confusion. Again, adds to the adults' confusion too. This one I thought was really interesting. And again, this is a direct pull from the book. It says you can't add fractions by adding the numerators and the denominators, but when you multiply fractions, you multiply the numerators and denominators. Well, this just is crazy talk. And just in case you're not completely confused, try division, where you have to invert and multiply. And you can only do it one way. The other way doesn't work. So fractions can be presented as very confusing. Part of the problem is our definition. The everyday definition of fractions is that it's less than a whole, or it's just a little tiny bit. So like if I say I got a fraction of my jobs done today, I'm not pleased. I got a small amount done. That's the everyday definition of fractions. So we've got 1/3. So the 1 represents the number of pieces. The 3 represents the total number of parts. And this kind of implies that you can't have more than the whole, because how can you have more pieces than the total? So the everyday definition of fraction doesn't work very well. But when you look at the math definition of fractions, now this is going to start to make sense because the math definition is one number divided by another number. So if I have one, I got one, I wrote one, and I divide it by, in this case, I'm going to divide it into three equal pieces. So I've got one divided by three gives me that section, which we call 1/3. Now, the other ones are also 1/3, but you can see that these are the thirds, 1/3. So let's try it this way. Let's try it this way. Let's do two. So I've got two holes. I got one, two holes. I'm going to take this whole length and divide it into three equal pieces. So I've got 2 divided by 3 is 2/3. There's my section. I'm going to call this 2/3. Now, the other sections that I did not choose, but they're also 2/3 sections. Now, some of you are going, okay, but isn't 2/3 the same thing as 2/1/3? Well, yes, it is. Just hold on a second. So if I take this, I'm going to divide it back into 1. So now I've got 1. I still have my section that I've still got my golden section here. So I've got 1. And if I divide it into 3 equal pieces, that represents 2/1/3. So you can look at it kind of backwards and forwards, forwards and backwards. There's different ways to look at fractions. Unfortunately, when children are taught that a fraction is always part of a whole, the transition to looking at it this way with division is not as easy. And some of you are going, okay, I kind of got that. Well, again, probably because you don't view fractions as division. I didn't either. I now have learned to look at it that way, but the transition was difficult. So let's look at how we teach fractions. Well, first of all, here's what not to do. And we got this image. Again, this is in the Start Math Right book, but we got this from a textbook. It's got a picture of a little fish tank, drawn kind of weird, but work with me. It says, what fraction of the fish are blue? So the kids are supposed to count all the blue fish. Well, there's 2 of them. And they count all the fish, and that's 5. And somehow they're supposed to know that 2/5 is a number. Why would they think that 2/5 is a number when it's not? They don't just see it as a 2 and a 5 that happen to be stacked on top of each other. It doesn't, this model does not help the kids see that 2/5 is a number. It looks like it's a process. So that's what not to do. Here's another example of what's not to do. And again, this comes from another textbook. It says, this is fourths. Now, I'm not saying this. This is what this other program was saying. It's saying this is fourths. Okay. This is thirds. All right, that makes sense. But look at it carefully. Look at the size of that green 1/3. How is that in relationship to the purple 1/4? Why would a child not think that fourths are bigger than thirds? Looking at this. And here, let me just kind of help you. I'm going to move that over. Look at that. Why would a child, under any circumstances, think that a fourth is smaller than a third? Which kind of comes back to our hamburger problem. So this is why we have such a difficulties with fractions. There is a better approach, and we're going to talk about more, but I'm going to talk about a real easy one here. If this is 1/3, what's the whole? Well, hopefully you're talking to your computer and you're saying, well, it would be 3 of them. Exactly. You can line them up however you want, but here's how I have 3 1/3 is a whole. Okay, that probably wasn't too difficult. Try this one. If I have 2/3 as that orange shape, what's the whole? Did you come up with this? Now, some people have been so upset about this orange shape that looks like the old-fashioned Pac-Man They've gotten so upset with this orange shape, saying that's not a hole. A circle is a hole. Actually, Dr. Cotter had one person that became so angry with this orange shape being a hole that they refused to believe the solution and stomped off. Well, that's sorry, it's still 3/3, because if this part is 2/3, I would need 3/3 to make the whole, and there it is. There's a subtle but insidious effect that occurs when you're using circles, but it's crucial to remember that the whole can be any shape, whether you think it should be a circle or a part circle. It can be any shape as long as you've got all the parts. Here I've got 3/3. So here's how we're going to teach fractions. We're going to use a linear fraction chart. We're going to take this chart and ask the kids to put it together like a puzzle. So I've got 1, 2 halves, 3/3, 4/4, 5/5, 6, 7, 8, 9, and 10. We need to see the whole picture as well as the details. And those with learning challenges really need a consistent visual model so that they can visualize and reference for more advanced fraction topics. So we need to be able to show the child how the fractions are and how we put them together. Now, notice when I was going through the numbers, let me back up a second here. I said half, third, fourth. I didn't say quarter. I said half, third, fourth, fifth. Oops, going to go the wrong way. Half, third, fourth, fifth, sixth, seventh. But if I say, let me go down to the bottom. If I say half, third, quarter, fifth, sixth, it's like you can't get your rhythm. You can't catch it. But if I say half, third, fourth, fifth, sixth, oh, I got the pattern. I can see that. So use 1/4 when you're teaching and thinking about math with fractions. If you want to say quarter past an hour, that's fine. You don't have to say 1/4 past an hour. If you want to say a quarter burger, that's fine. You don't have to say a 1/4 burger. But keep in mind that a quarter and a 1/4 are the same. But in math class, when looking at fractions, refer to this one as 1/4 or 3/4. In the book, Dr. Cotter has little stories, little excerpts, and this is one I just copied out because I just thought it was so wonderful. It reads, I asked John, age 7, to build the fraction puzzle and timed him. Anna, age 6, having never seen the fraction puzzle before, wanted to beat her brother's time. She arranged the pieces face up and said, time me. She quickly placed a few pieces. Stop! And then seeing a better way, she stacked the pieces by size. So she put the halves together, then the thirds, the fourths, the fifths, the sixths, and then tried to do it. And then she said, stop, because she had a better way again. So then she put the stacks in order with the halves first, the second, or excuse me, the halves, the thirds, the fourths, all the way down to the tenths at the bottom, and said, time me. And to her great delight, she solidly beat her brother's time. That's the kind of thing we want the kids to do, is to explore and work with the fraction chart so they can see how it's put together. Now, sometimes people will look at that and go, oh, well, that really wasn't very pretty. Let's give it some color. Well, the problem with this is you start to focus on the colors. You don't really see the beauty of the fractions themselves and how they're put together. So we want to leave it blank so I can see, like, look at the arch in here. You've got these curves in here. You've got all these beautiful patterns within the chart. And that's what we want the kids to see. So let's go and look at some of the things that we can do with this fraction chart. Oops, just a second here. There we go. So let's look at what things we can do with the fraction chart. So first, let's start with how many fourths are in a whole. Well, now, if you've been to some of the other classes, you know we talk about subitizing, but I'm going to go ahead and count this one out because it kind of makes it a little bit easier. How many fourths are in a whole? 1, 2, 3, 4. Oh, 4/4. Okay, that makes sense. How many fifths are in a whole? Again, I can count it out and I can see my answer is going to be 5/5. Make a whole. How many eighths? Again, I can count it out and I can see how many I have. Now, it seems like almost silly to talk about this. Like, well, of course you can see that there's going to be 4/4 and 5/5 in a whole. But NAEP, the National Assessment of Educational Progress, tested 9-year-old students, and they were stunned at the children who did not understand this. In 2000, only half of the kids understood the question or answered it correctly. How many fourths are in a whole? In 8 years later, they tested another group of fourth graders, or excuse me, 9-year-olds, excuse me. In 2008, they tested 9-year-olds again, and 44% of the kids knew the answer. How many fifths are in a whole? So I don't know what the numbers are now, but this is sad. This is a basic thing. If you don't know how many wholes are in one with fractions, everything from here on is going to be complete chaos. What's more, 3/4 or 4/5? 3/4 or 4/5? Oh, well, of course I can see 4/5. That's easy. The chart makes it so simple. Here's another one. What's more, 7/8 or 8/9? 7/8 or 8/9? Oh, 8/9 is just by a hair. Again, you can see the pattern. You can see how this all works together. I want to show you guys equivalent fractions. What is an equivalent fraction for 1/2? So in other words, what's another way of saying 1/2? Well, let me just draw a line down here. So I've got 1/2. Well, that would be 2/4 is the same thing. 3/6 is the same thing. 4/8, 5/10. You can see it with the chart. There's no rules to have to memorize. I can see it. And that's where we want the kids to be able to see this and work with it. Let's do another one. What's the equivalent fractions for 2/3? So here's my 2/3. I'm going to draw the line just because it just makes my life a little bit easier. Oh, I can see. Oh, look at that. I've got 4/6 and I've got 6/9. It's the same thing. It's the same amount. Now I'm going to show you something else. And again, this is coming out of the book. This to me just tickles me to no end. You can do equivalent fractions on a multiplication chart. So this is just your ordinary multiplication chart. So, here I've got 7 times 6 is 42 and 9 times 9 is 81. So it's just your multiplication chart, nothing fancy. But look at this. I've got 1/2 is the same thing as 2/4, 3/6, 4/8, 5/10. And of course, I could keep going from here. Let's do another one here. Let's do our 2/3 that we did before. Now, the rule with this is they have to be in the same column. They don't have to touch, but they have to be in the same column. So here's 2/3 is the same thing as 4/6, 6/9, and I could keep going, 8/12, 10/15, and keep going. I can also go backwards. I can reverse this. So if I say 6/9, what is it the same as? How can I simplify it? How can I bring it down to something, a simpler way to say 6/9? It'd be 2/3. What about 4/6? Same thing. You can see it's going to be 2/3. So let's extend this a little bit. Let's take a harder one. 1840 seconds. Now, some of you are going, yeah, no idea. No idea, not a clue. Well, just hold on. Let's look at the chart. Remember, find them in the same column. Do you see 18 and 42 in the same column? Remember, they don't have to touch. They can be separated, just have to be in the same column. So 1840 seconds, if you look at, you'll find it there in the 6, and I move it off to the left, I can simplify 1840 seconds as 3/7. Isn't that cool? Let's do another one here. Let's do 28/63. This, when I was a child, would have been a reason to cry. As an adult, I look at it and it's like, okay, I can do this. I look on the chart, 28, or in my head, I'll even look at it and say, okay, 28 and 63, where can I find them? See, here's, 28, 63. Oh, right there in the 7s column. There we go. 28, 63, 63rds. I take it down to the left. I simplify it to 4/9. Now, some of you are going, oh, what kind of magic is this? Well, remember I said they have to be in the same column. So the reason this works is because I'm taking, and they're in the 7s column, and I'm taking 28 and 63 and dividing them by 7 and coming up with 4/9. ninths. Isn't that just the coolest? These are the kinds of gems that are in the book that is coming to Start Math Right. So with the fraction chart, the linear fraction chart allows for the big picture of fractions to be seen so I can see the whole thing. It gives the whole view of fractions and it incorporates all the different meanings of a fraction. So what questions can I help anybody with? I see we have one here from Laura. She said, we're transitioning to decimals in E. Just a second, I got to move it so I can see it better here. We're transitioning to decimals in E and are now understanding fractions to be understanding fractions to be decimals to money feels so natural in this process. I love the approach RightStart takes such a slow, straightforward way. Well, thank you, Laura. I'm glad that's making sense to you. And Michelle said, this is magical. Thank you. Any other questions? And you're more than welcome to type them in the chat, or if you prefer to unmute or take your video on or off, whatever works for you, just yell out your questions. As always, if you have any questions, please give us a call. Let us know what we can do for you, whether it's, how do I incorporate some of these ideas into what I'm currently doing, or how do I bring it in my classroom? How do I use it with my children who are in a classroom? How do I supplement? Let us know what we can do. And thank you so much for everybody. Have a great day. Take care.